For years, China believed it had already won the global manufacturing race, not because it was more creative and not because it had better ideas, but because it had mastered scale. Faster output through more factories, lower costs through more labor, relentless volume powered by sheer repetition. It worked. It worked so well that it convinced governments, corporations, and entire industries that manufacturing had reached its final form. Speed, according to that model, came from multiplication. More lines running in parallel, more people per shift, more redundancy to catch mistakes. If something slowed down, you added capacity. If quality dipped, you added inspectors. It wasn't elegant, but it was effective. That belief hardened into doctrine. Then Tesla showed up and quietly broke it. Not by being 10% faster, not by doubling output, but by redefining what fast actually means, by questioning whether scale itself was the bottleneck, and by proving that the most expensive part of manufacturing wasn't materials or labor or even energy. It was complexity. Elon Musk has said something that on the surface sounds reckless, that Tesla is moving toward finishing a car under 30 seconds. Not a component, not a subassembly, a finished vehicle exiting the line. That number should make anyone who understands manufacturing uncomfortable. Even the most efficient factories in China still take close to 2 minutes per car. And those plants are considered world-class. They operate around the clock. They employ thousands. They've been refined for decades. Tesla isn't trying to compete with that system. They're bypassing it. China's advantage was always scale. Tesla's advantage is subtraction. Tesla doesn't add more people to go faster. They remove people entirely. They don't add robots, they eliminate robots. They don't optimize welds, they delete welds. And when you remove enough steps, something strange happens. The line accelerates past human tolerance. It moves so fast that humans physically cannot work inside it anymore. That's not efficiency. That's a different category of production. And it all traces back to one machine.
Gigapress 2.0. This isn't just a bigger die-casting machine. It's a statement about how Tesla thinks manufacturing should work in the future. Elon Musk once compared it to making matchbox cars, and that comparison wasn't exaggeration. The goal is to reduce automotive manufacturing to something closer to injection molding than assembly. And this machine isn't reserved for one experimental model. Musk has confirmed it's the foundation for everything Tesla builds next. So what actually changed? To understand Gigapress 2.0, you have to understand why the original Gigapress mattered in the first place. Before Tesla, car manufacturing looked roughly the same everywhere. Hundreds of stamped metal parts welded together, each weld introducing a stress point, each joint flexing microscopically. Over time, vibration turns into noise, misalignment, fatigue, and failure. That slow degradation is not a bug in the system, it's the business model. Tesla replaced that entire philosophy. Instead of welding dozens of components together, Tesla cast massive sections of the vehicle as single structural pieces. No welds, no bolts, no stacked tolerances drifting over time. The Model Y alone eliminated more than 70 complex parts this way. The result wasn't just faster production, it was a 40% reduction in manufacturing cost. Fewer steps, fewer inspections, fewer opportunities for error, and more importantly, fewer places where the car could slowly die. That was already disruptive. But the Model 2 forced Tesla to go further. The Model 2 isn't just smaller, its proportions are extreme. Very short front and rear overhangs, a compact footprint, almost no wasted space. That geometry is ideal for casting the entire underbody as a single piece. There was only one problem. The 6,000-ton Gigapress used for the Model Y wasn't powerful enough, so Tesla didn't upgrade it. They replaced it with something else entirely. Gigapress 2.0 generates roughly 50,000 tons of clamping force, more than 8 times the capacity of the machine used for the Model Y. And according to Elon Musk himself, this press isn't designed to cast one underbody at a time. It's designed to cast multiple frames in a single cycle. That detail changes everything.
Because once you can cast multiple full underbodies at once, the entire cost structure of a car collapses. Assembly time shrinks, factory footprint shrinks, labor shrinks, quality variation shrinks. This is why skepticism around the Model 2 pricing evaporated the moment Tesla confirmed the new press. $30,000 stops sounding unrealistic when you eliminate most of the process that used to justify higher prices. But here's where most explanations lose people. They start listing technical details without explaining why they matter. So let's slow down and connect the dots. Gigapress 2.0 begins with aluminum alloy melted to extreme temperatures. Virgin aluminum blended with recycled material from previous castings. Not because Tesla is chasing sustainability headlines, but because recycled aluminum behaves more predictably under pressure. Two furnaces run in parallel. One drives heat, the other stabilizes it. Temperature drift is the enemy here. Drift creates defects that don't show up immediately. They show up years later. Before each casting cycle, robotic systems coat the mold with a release agent so thin it's measured in microns. That coating prevents microscopic surface defects that would otherwise become crack initiation points over time. Then the mold is vacuum sealed. Air is removed entirely. Air pockets don't matter in the short term. They matter after 100,000 miles. Molten aluminum is injected at extreme velocity, filling the mold in milliseconds. And this is where clamping force becomes everything. Without enough force, the mold flexes. Flex creates internal voids. Voids become failure. That's why legacy automakers can't just buy this machine and copy Tesla's process. Their presses physically can't generate the force required to guarantee consistency at this scale. Once cast, the structure exits the mold at extreme temperatures and is immediately quenched. Rapid cooling increases strength while reducing internal stress. The aluminum becomes stiffer, not more brittle. No welds means no rust paths. No welds means no fatigue zones. No welds means no slow misalignment that quietly destroys cars after 150,000 miles. Every gram of leftover aluminum is recycled back into the system. Nothing waits, nothing piles up, nothing adds delay. And this is where Tesla separates itself from China. China scales by duplication, Tesla scales by elimination. A Model 2 reportedly contains fewer than 90 structural parts. A Model Y uses more than 200. That difference isn't cosmetic, it's existential. Fewer parts mean fewer failure modes, fewer inspections, fewer dependencies. And once those disappear, speed stops being dangerous. But speed introduces a new kind of risk, because systems this optimized don't fail slowly. Traditional factories absorb mistakes, humans intervene, lines slow down, problems are corrected quietly. Tesla's system doesn't allow that. If a tolerance is wrong, it doesn't affect one car, it affects every car. That's the bet Tesla is making.
They believe data can replace intuition, that sensors can replace inspectors, that feedback loops can correct drift before humans even notice it. They believe learning can happen faster than production. If they're right, quality improves as speed increases. If they're wrong, failure doesn't creep in, it arrives all at once. This is why competitors aren't attacking Tesla publicly. They're watching. Because copying this system doesn't mean buying a machine. It means rebuilding factories, retraining labor, and writing off billions in infrastructure that no longer fits the process. China's advantage was volume. Tesla's advantage is inevitability. And that's why the Model 2 matters. Not because it's cheap, not because it's electric, but because it tests whether cars can stop behaving like consumables and start behaving like infrastructure. If a vehicle can be built in seconds and last decades, the replacement cycle collapses. Service revenue shrinks. Parts demand disappears. Entire ecosystems reorganize. This isn't disruption, it's subtraction. Tesla isn't designing the Model 2 for desire. They're designing it for repeatability, for systems that run indefinitely without slowing down. That's not how consumer products are built. That's how utilities are built. Which brings us to the uncomfortable question. If Tesla succeeds, does the auto industry survive in its current form? Because if speed no longer sacrifices durability, then complexity becomes unjustifiable. Factories designed around hundreds of steps become liabilities, and everything built the old way becomes overpriced overnight. And if Tesla fails, this becomes the most expensive manufacturing gamble of the decade. There is no middle ground. Either cars built in seconds become the most durable machines ever sold, or speed finally outruns trust. That verdict won't come from factory tours or press releases. It will come from driveways, from repair bills, from time. And by the time most people realize which side won, the shift will already be irreversible. So don't tell me whether you like this idea. Tell me whether you trust it. Would you trust a car built faster than your coffee finishes brewing if it proves it lasts longer than anything built before it? Because that answer doesn't just decide the future of Tesla. It decides who survives after 2026.